Good afternoon, ladies and gentlemen, and welcome once more to Wafu TV. If this is your first time, this is Wafu TV, where we simplify, exemplify, and demystify elementary mathematics just for your understanding. Last lesson, we talked about parallelogram and the different aspects of parallelogram. Today, we are going to be doing trapezium. By the end of the lesson today, we should be able to calculate the area or height of an isosceles or a right trapezium. First of all, before we go into solving, there are three main types of trapezium. That is the isosceles, the scalene, and the right trapezium. So our focus will be on the isosceles and the right trapezium. And we are going to be calculating either the area or the height of these trapeziums. The first aspect is, of course, the area of a trapezium. And like I said last time, we have the rule in most instances to guide us to the answer. So the rule to finding the area of a trapezium is half of parallel sides times height. Or in short, you can just write it as A equal to half of sum of A and B times H. Now we're going to draw a right trapezium and identify the different side, the height and the parallel sides. Here is our right trapezium. What makes us identify it as a right trapezium is because this perpendicular line joining the parallel sides meets the parallel side at right angles. A is a base, which we call a parallel side, and B is another base, which is a parallel side. This line, which measures 6 centimeters, is the height. So how do we find the area of this parallelogram? The first thing is to state the rule, and we've said the rule is A equal to half sum of parallel side, which is A and B, times height. Let's substitute the various figures into these letters. This will be equal to A half into A. We can put A to be 12 plus B, which is 8, and we multiply that by the height, which is 6. If we substitute into this, it will be half plus 12 plus 8 is 20, here multiplied by 6. Half of 20 here will be 10, and 10 times 6 is equal to 60 centimeters squared. Never forget to square the unit if it has to do with the area. This is basically what you can do as far as this is concerned. There is another method that we can use. Let's look at it together. Assume this is the same and they ask you to find the area. You can break the shape into two different shapes and find the area of each separately, then find the sum of it. So on this other side, we have 8 and 6, which means it has a long and a shorter side, which is a rectangle. And on this side, we can clearly see it as a triangle. So you find the area of a rectangle separately, area of a triangle, and put the two together. Now, with the triangle, we'll need the height and the base, and here the base is not given, but we'll use the dimensions given to find the base. Area of figure 1 is equal to length times width, that is 8 times 6, which is equal to 48 centimeters squared. That is for just this side. Now let's look at area of shape 2. Shape 2 is a triangle, and it is going to be half base height. That is what is, let's first of all write half. The base is what we don't know. Now let's look at it together. If from here to this place is 8 and from here right across is 12, then we can easily find from here to here. We subtract 8 from 12, and this is going to give us 4 centimeters. So the base of the triangle is 4 centimeters. This will be half times 4 times 6 for the height. Half of 4 is 2, and 2 times 6 is equal to 12 centimeters square. Therefore, area of trapezium will be equal to 48 plus 12, which is equal to 60 centimeters square. This answer and this are the same. It means even if you use the second or the first method, you arrive at the same answer. It is only for you to decide whether you break the shape into two shapes or even 3 in some cases, because, for instance, you may equally have an isosceles trapezium. If it's an isosceles trapezium, then you can break it into 3 shapes and find the areas of triangle 1, triangle 3, and rectangle, which is number 2. Then you put all together to find the area of this trapezium. So this is it for the area of a trapezium. Now let's move on to how to calculate the height of a trapezium. Height of a trapezium. Here is our isosceles trapezium, and the parallel sides are 7 and 11 respectively, while the area is 72 meters squared. We are asked to find the height, that is that line connecting the parallel sides, and it is x. How do we find this? We're going to use our knowledge of how to calculate the area to find the height. First, what did we do to find this area? We took half of sum of parallel sides A and B, and we multiplied it by the height to find the area. Now let's substitute. We have half. Parallel sides are 11 and 7. The height we don't know is x, and this is equal to the area, and our area is 72. Half again into 11 plus 7 is 18. 18x equal to 72. What is half of 18? This is 9. 9x is equal to 72. To solve this at this level, this is a simple or a one-step equation. To have x, we simply do away with the coefficient of x, which is 9. If we want to have x on this side, we will divide by 9 and divide this side by 9. So that 9 here is 1, 9 here 1, 9 here 1, and 9 into 72, 8 times. So that x is equal to 8 meters. So this is what you can do to find the height. Let's look at another example, and of course the last for the day. Just as we substituted to solve for this, let's do the same for the right trapezium. The area, as we know, is equal to half of sum of parallel sides A plus B times height, which will give us the area. Our height here is x, so we'll substitute h with x because here it's given as x. Half of parallel sides are 9 plus 3, and our h here is x. We substitute with x is equal to the area, which is 24 decimeters squared. We move further. Half into 3 plus 9 is 12. X is equal to 24 decimeters squared. Half of 12 is 6x, equal to 24 decimeters squared. And if you divide both sides by 6, as in a one-step equation, you're going to have this 6 gone away. 6 here 1, 6 here 4. And x, which is the height, will be equal to 4 decimeters. Do not be tempted to put squared here because we are just talking about height and not the area. This is what we had for you today, and we believe at least you've learned something. If you did, give us a thumbs up, subscribe to our channel, and share so that someone can equally benefit from this. You are free to share your thought with us through the comment section, and see you in our next lesson where we shall be finishing up with quadrilaterals. Until then, it's goodbye from us.